Hello, everyone. Thanks for joining me today. And I would like to start this session with a story. Like a long time ago, I used to develop Flash games. So any ex-Flash developers in the audience? Yeah, a lot of them. Nice. So it was a long time ago, though. So one day I learned this really cool optimization technique called object pooling. And I actually used it everywhere. I optimized the hell out of my game. But at one point, the more experienced developer came to me and pointed at my code and asked this question, like, how do you think, how many times an object is actually requested from this pool? And the answer was 3 times throughout the whole game. How do you think how efficient this optimization was? Well, probably not very. And today the talk is actually not about profiling, debugging, optimization, or tools. The talk is about how to be efficient. Because what is the difference between a senior developer and a junior developer? Basically, how efficient he or she can solve problems. So to be efficient, you need to first have enough experience, so make more games, have enough knowledge. I guess this is why you are all here, and know the right tools. We can help you with the tools, and I'm going to show you how to use the tools we provide as Unity. So the tools I'm going to show you are the following. So of course, the profiler. Like everyone knows the profiler, I hope. There's frame debugger, which shows you what's being drawn and why. There's memory profiler, which is secretly hidden under this link you probably cannot see. But we'll get to that. And there's a new thing in 5.6 called physics debugger. It shows what's going on in your 3D game and why your objects are not sleeping. So if you have like a large 3D world, you can use that. And of course, there are different platform tools. And every platform supplies a set of tools. And my favorite ones are from iOS. I use them a lot and like them a lot. But today, we are not going to talk about them. So if you know how to use the tools, the first thing is you can gather correct data. And if you have correct data, you can ask right questions. And I get asked questions a lot. Because I'm a field engineer, I work with customers, and I try to solve their issues. I get a lot of questions. And of course, I like questions like the first one. Like, here's the data from Profiler or from other tool. Like, why is it happening? But unfortunately, I get a lot of questions like the second one. And unfortunately, guys, if you ask such questions, I cannot really help you. So to make everything more entertaining, I followed this tutorial online and made a game with this cool guy. But since I'm not a very good game developer, I made a lot of issues. But the good news is that I know how to use the tools and how to find these issues, and this is what I'm going to do. So let me show you the game. This is my mad Photoshop skills. Oh, damn it, I already died. Jesus. This wasn't part of the tutorial. OK, so you can, Jesus. So you're probably familiar with gameplay. So as you understand, I had to play this a lot while testing. So I got really frustrated and made like an easy mode. But anyway, even with the easy mode, I always, like, sometimes I manage to screw up. So I made like this easy mode. And I actually like this gameplay a lot. This gameplay suits me much. This is what I like. And to add like more company, I added highly sophisticated artificial intelligence using neural networks. Because I'm joking, it's like stupidest bot possible, but it's kind of believable. So this is what we are going to look at now. But let's start with the profiler. So you all know that to get to the profiler, you go to Window, Profiler, and you have this interface here. So I'll just quickly show you like the different buttons. So first of all, when we press record, we actually record what's going on in our game. Deprofiler gives us more information, but it makes everything like slower and only works in the editor. The cool thing is that you can actually profiler editor itself because it works in the same ecosystem. So if you're writing like a editor extension, you can press like profiler editor, and you can see that this is what editor is doing right now. So we can like stop recording and check what's going on here. So this is like CPU profiler. You can see profiler window, repaint profiler windows. So we're basically using profiler to profile profiler. But we are not going to do this right now because it's not super interesting. So so you can see here are like several profiler tabs. And the most interesting is, of course, the CPU profiler, like this one. You can add them with this menu. This rendering profiler, which like shows you some information about how many like draw calls, how many triangles you have. It's not really usually that important, but you can get some information from this. Another really important thing is memory profiler, and I will show you how to use it and what information you can get from it. And the new one, which was added in 2017.1, which I am using right now, and I really hope it's in a stable state because it's releasing soon. So the new one is UI profiler. So it actually shows you what's going on like with your UI elements. So here we have like 2 canvases, but they're kind of simple. I don't have a better example right now for a UI profiler, but you can try it yourself on more like complicated projects with different lists and stuff. So you can see that it even says why it had to start a new batch, because we have like different texture. And these are my UI. This is my UI. Like it says CPU profiler, this background, and a score. So let's run our game and see what we can get from CPU profiler. So I hope you guys see. I made a special like a layout here to make it easier to follow. Let me select CPU profiler, record, and press play, get my splash, and I start playing. You can see that I'm playing and I'm getting real-time information in the editor. And at any point, you can pause your game and see what's going on. So let's see like what's going on like here. So I'm looking at some frame, and there's like scripts and other things. You can actually like turn this off. I don't want to see rendering. I don't want to see scripts. I actually want to see scripts after rendering. Like you can move them so as you wish. But what we want to see here is basically 2 things. So if you select a frame, you get like different calls here, and you see time and GC allocations. So you see that something is taking like 405 milliseconds, and after that, like some other things take less and less and less. So basically, the first things we are interested in these guys. We are not really interested in like these things because they are, like, contribute nothing to our CPU load, and we will examine these ones first. And the next thing is GC allocations. It's how much memory your scripts are allocating a frame. So you can see that like this thing allocates like ½ kilobyte, like 1 kilobyte, 1.8, 384 bytes, and these guys allocating nothing. So what we need to check right now are these ones and the ones allocating things. Because if every frame you allocate stuff, at some point garbage collector will kick in, and you'll have a spike. It might be here somewhere. Well, I probably will find the spike at some point. No, we didn't have spikes yet. OK, first of all, let's examine this thing. So it says something, post late update, player update, canvases. OK, we'll run it canvases. So without any like special knowledge about how Unity internals work, you can see that it has something to do with canvases. So using arrows, You just go like down, canvas, layout, graphic. Oh, text. It's interesting. Or outline, shadow. You can see that these guys take the most of the time of this specific item. And I know that in my game I have this text with scores, and we can, like this one. So to figure out what's going on, we need to see how this text is updated. So I know that the text is updated in somewhere. Need to get used to the resolution. So I can go to my script. Yeah, I think you guys can see it's fine. So here I have an update where every update I update my score property. And what score property does, it sets the text. So every frame I update this text, UI has to recalculate all the meshes it uses this canvas, and this is where I get this performance. So if I, for example, like comment this and go back to Unity and restart, you can see that the graph looks differently. So, and now we can see that something else is taking time. So we got rid of this text regenerating all the meshes every frame. So we saved a lot of time on our game. Actually, I'm not going to fix everything I find because we would need like 3 hours or more to do so. So some things I'll just point out so you know how to find these things. Okay, we got rid of one thing. Let's check out this guy. So the name of this item tells us pretty much what this item does. By the way, if you're on 5.6, all these things are called a bit differently, but anyway, you can figure out what's going on. So it's update, script update. It means like some of our updates are doing something. So I can see that bot update. It's so bot is my like this super complicated AI, and I can see that it takes kind of a lot of time. And the thing is that you can see that transform get position takes a lot of time for some reason, and this is odd. So what I need to do is to go to bot update. Just let bot go to update, and basically I see this. There's some complicated logic to position bots somewhere around like camera, and the immediate thing I see that I have a lot of references to transforms which probably should be cached. I have a lot of references to positions, which probably should be cached, and camera main. So people ask this question a lot of time, like, should I cache transform? The answer is yes, if you see it in Profiler. And we actually see it here, because usually you don't see it. It's like a super lightweight. But we can see it here, so we probably should cache these things. And another thing which we don't really tell you guys, because we want you to suffer, is that camera main doesn't cache camera, actually. So every time you call it, it goes and finds the object with the main camera tag and queries for a camera object. Okay, so we will need to fix this. Somehow, like cache this or change this code altogether. All right. Let's go see something else. Like bot update is probably fine. All these other things like column update, just like a few hundreds of milliseconds, probably not much. And here I don't actually see anything worth attention right now. Okay, let's go and see what's next. The next is camera render. It's the stuff which renders everything in our game. And usually the problem is that we cannot do much. The usual answer is render less stuff, but not everyone can do this. And we actually will get back to rendering soon when we are going to look at frame debugger. This will help us a lot. The interesting thing here, though, is that we have 4 calls to camera render. And this is odd. And we actually have 4 cameras. And you can check in hierarchy that, OK, this one is main camera. This one is fine. This one is just some camera. I don't know what is that. Oh, this is a splash camera. So it was used to render splash, but it's just useless right now. Another one is specifically called useless camera, because it doesn't do anything. And by doesn't do anything, I mean exactly it doesn't do anything. Like it's Kali mask set to nothing, so it doesn't render anything pretty much. And another one is used to render UI in my additively loaded scene, which is also probably a bad idea. But the thing is, you can see that these cameras, which don't do anything, they contribute to the CPU load. So this one is main camera. This one is like other cameras. And this is not the only place where these cameras contribute to CPU load. So if you have any cameras which you used in the game at some point, please make sure that you disable them or remove altogether. OK, so since we don't have much time, let's just take a look at something which allocates OK, we probably wait a second. This is mouse. OK, we can check out what this thing is. So you can see that this guy allocates almost 1 kilobyte. We can go to behavior update, player. It's like player getBird component. Whoa. Why is this get component allocates half kilobyte? This is a good example of a thing you can see in the editor, but you will not see in the build. And you really need to connect to your actual build game, which you can do with this connect player if you run in if you build your game in development mode, and see what's going on there. Because some of the allocations you can see in the editor, they will not be shown, and they will not be basically in your build. So let's take a look what this thing does. So we have this player update. In the player update, we have some kind of get component. Let's see where the player update goes. Player update. So you can see that in player update, when we click or press a button, I wanted to play some kind of sound, but I basically forgot about this. But this code, so it tries to get a component which is not there. So Unity gives you a special null object. So to create this, it allocates a small amount of memory and gives it to you. But basically, it's just a null object. You will not see in the build. OK, so we took a look at some of them. Like, oops. What's this 1.4 kilobytes? What's that? Physics, send contact callbacks, convert collision or script. Yeah, this is unfortunately the thing we can do nothing about. So when our 2D bots collide with columns, they get these on-collision enter callbacks. And on-collision enter callback receives a managed object, which is created here. And unfortunately, it has to allocate some amount of memory. OK, let's take a look at something else, like the next 1.8 kilobytes. OK, send mouse events. Get component. This goes to the same thing. So you probably know the send mouse mouse events, like on mouse click and others. If you're making a mobile project and using this, please stop. And actually, editor, if you try to compile your game and you have any of these callbacks on any scripts, editor will warn you. The editor will warn you. Damn it. Because here you can see what it does. Like, if you have any of those callbacks, like every mouse click, for example, it has to execute a lot of scripts and basically raycast through all cameras. But not only raycast through all cameras, it also looks for a component which is, I think it was, yeah, it was GUI layer. So we don't have any GUI layers on the cameras, so this is why we get the same thing we saw with the audio source. Okay, so this is probably not significant. So we found something. We have something to work with. But the really cool thing about the whole CPU profiler is that you can load and save your data. These are actually here from starting from 5.6, I think, but before that we had this special API to do the same thing. So right now we can, so we could connect to iOS device, which I did at home, save the data and see what's going on. One interesting thing you learn the hard way is that the data is not compatible between versions. So I did it in 5.6 and forgot my device at home, so we can open 5.6 and do the same. So open profiler, load, it's my Flapo game, startup data. It's loaded. One really cool thing about Unity 5.6 and beyond is that we can actually see what's going on at the start, at the very beginning. If you're connected to iOS, for example, to iPhone or Android. Because before that, Profiler just didn't have this information. So you had to use instruments time profiler to get pretty much the same thing. And right now, you don't. And to show what's going on at startup, let me show you another view of the same tool. So here, we have timeline view, which shows you with nice boxes like what's going on in time and on what threads. There's pretty nothing going on in this thread. So we can see, it's a bit hard to zoom without a mouse, but you can see that we have initialize auto-CPP, initialize player. It takes some time. We can go. This is we don't know what this is, but it know that it happened between the initialize player and the initialize graphics. So we go further. You can see that initialize graphics here. So we're loading global managers. Yeah, we need to fix this. Init F mode, which you can see it takes some time. And after that, something we don't know about, and something loaded. So basically, if I'm not mistaken, this is the splash screen, and this is the first scene which was loaded. Let's see what's happening in the first scene. Am I looking at the right thing? Yep. I should do this. Yep. OK, so this one is loading, update, preloading. So it loads something, loads level, enables kind of things, enables texts, which takes surprisingly a lot of time. So after that, we can see, so this is our code. You can see coroutines delayed calls, so we get some start methods called here. There's splash start, and splash does instantiates this really cool Photoshop art with Doge. It instantiates it. And after that, we have bot spawner. The interesting thing here is why bot spawner takes so much time. And we will take a look at this shortly. So let's go back to the newest, more powerful, and more shiny version of the Unity editor, and run the same game here. Oops. So this is where our frame started. You can see I selected it here. So in the editor, we can see what's going on when the first scene starts. So here are our scripts. We have already seen this coroutine delayed calls. You can see bot spawner start. It allocates a lot of memory, and it kind of takes a lot of time to start. So we go deeper. OK, bot spawner create pool. It must be creating some number of objects in the pool. And apparently, it creates like 1,000 of them. So probably, I don't need all the 1,000 of them here. So I can just set like 100 something to optimize this and save a lot on loading time. But we are also interested in why this takes so much memory. So we can go deeper. OK, object instantiate, object clone instantiate, awake, physics, both awake. Whoa, what's this? So you can go to bot awake and check out the code. Bot awake. So you can see that this line, a poorly written link-u code, generates a lot of garbage, pretty much. We usually, when we talk to teams, we kind of discourage people using link-u, not because it's bad or something, but because it's really easy to write something which, under the hood, allocates this and that array, and you will see it in the profiler. So maybe this example is kind of fine. So what this does, it queries Unity for all the components extending bird class, takes the first enabled one. Because a bot can have different realizations of the bird class with different functionality. Another cool thing you can use is this API. So probably some of you know that we used to have this profile begin sample and end sample, using which you can create your own your own labels, pretty much. So you can see that here I have a special link-u label. So this one shows what's going on underneath. But if I turn off deep profile, I will only see the link-u label. And this is how you can kind of emulate deep profiling on device or here in the editor. But right now the syntax is a bit different, and we are making this syntax obsolete. So what you need to do is to create a custom sampler. But of course it sounds better if you, for example, sample something every update, not just once. And you just use begin and end. Basically, pretty much the same thing. Yep. Well, OK. So this is how to use profiler, like CPU profiler. Basically, what you need to know is that sort by time, sort by GC allocations, and try to minimize both. This is super easy. The next thing I want to show you is, the next thing we can, which is useful. Wait. No. It's memory profiler. So let's run this game again and see what's going on. So I'm playing. I'm getting better at this game, don't you agree? I press pause. And so basically, memory profiler can give you some data on what's going on with the memory. You can see some data here, which actually is totally not relevant to us right now, because we are looking at the memory of the editor itself. So this is what the editor with everything, all the subsystems, and your game is right now using, how much memory. So you can see there's some kind of information, how many textures you got, how many meshes and materials, what's your mono heap size, and other things. It gets much better when you connect to something, which we'll do in a minute. But the really useful thing is if you go to detailed and you press take sample, and it even says your memory usage in editor is not as it would be in a player. We must do it with huge red letters. So you press take sample, and you can see something sort of useful even here in the editor. One really nice example of why it's you shouldn't do this. For example, here's I got a texture selected. It's a texture with I use it everywhere as a placeholder. So this is my texture. I press take sample editor. I wait a bit. So it took the sample. I go to here, assets, texture, and I see my texture here, grumpy guy, and it actually says that 29 things reference this texture. And this is just because I selected in the editor. So yeah, you shouldn't really do this in the editor. But to show you what all these things means, you can see that we have like a few groups. So first one is assets, what's in your like project. Another one is like scenes, what is in your scene. So you can create like some kind of materials, game objects, like different textures. They all will be in scene memory because they are not saved on disk. And you can see that these objects like take 11 megabytes, some gigabytes. But another really cool piece of information is this, ref count. So this says how many things reference this asset, this texture, or whatever. You can see that these textures are referenced, but this one isn't. So this is our Doge. I'm loading from resources to show the splash screen. But it actually is not saved anywhere, so it will be cleared with unload unused assets. But let's see how it looks in the actual build game. So I made a build. Here it is, called Flapper. We can run it. Can we? Where is it? Oh, here it is. Yeah. Okay, here's the game. Everyone can see something. And I'm playing. So I built it with, like when you go to build settings, you must select development builds and the auto-connect to profiler. So this is how you get the profiler from the game connected to profiler in the editor, and you will get all the nice data. So we can what? Yeah, we got our data, so we can play the game. You can see that we get data in real time. Our super intelligent bots try to avoid obstacles very efficiently. And when we, well, let's die a few times. Oh, this guy. Let's die again. Well, it looks pretty much pretty nice. It works really fine. But let's try to go to memory, detailed, take sample. You can see that it says auto-connected player. We take sample, took a sample, so we can pause the recording. And now we can see what's going on. So first of all, we can see scene memory. You can see that we have like 1,000 materials, 1,000 animators, 1,000 sprite renderers. This is because we have all these objects in the pool. But these are not free. As you can see, that materials cost some memory. Like animators and sprite renderers also cost some memory. But we are interested in textures. The thing is that we have these textures for whatever reason. And what we can see is that this part shows us, at least it should show us, what references the textures. The thing is that it says manage static references, which says nothing to me. And I got no idea what this thing is. The only thing I know is that I know where I use the DOS texture at splash screen. But this one says that two things reference my texture. And the first one is splash material, which is referenced by renderer, and another one is something managed static references. Okay, I know that the code for splash is somewhere here, and let's see what this does. So it loads a DOS texture, so it doesn't have a reference to this loaded texture, and this is why we've seen the DOS texture nobody references. It instantiates it and adds to the texture list. And this is static list of textures. So this is the reference which is shown at the in the memory profiler. But in this super simple example, it's really a no-brainer to figure out what's going on. But if you have, for example, many more scripts and don't really know what's going on here, we can use another tool which is called memory profiler. And this is the one which is hidden. But to get it, you need to go to that specific address I had somewhere. But it's on Bitbucket, I think, or on GitHub. So basically, Google memory profiler, and you will get it. So what this is basically a set of scripts called memory profiler, and you drop it into like pretty much any object. And what you get is this window. Window memory profiler. So you build your game with like IL2CPP. And I think I had a slide on this somewhere. This profiler. Yep, this one. So basically, you go to this URL. You download it. It uses a low-level API, which is available from since 5.3. And you definitely have to have the IL2CPP build for it to work properly. And after that, as I said, you have this memory profiler window. And basically, the workflow is that you run your game built on IL2CPP, and you press take snapshot after you connect to the profiler. But the good thing is that you can also save and load snapshot. And this time, I think it should be OK. So I have a special example of textures stuck in memory. So I'm loading this texture snapshot. So basically, it shows you this, that we have the memory rectangle, and most of the memory is occupied by textures. So here you can see that we have like 4 textures. They're like 21 megabytes each. So this is like a super simple example, but if you connect to your own game, to your own application, you will see much more than just textures. There will be a lot of like global managers referencing things and whatnot. But let's see what this thing actually lets you do. So for this to work, I have a special script somewhere. Bundle loader, and it demonstrates 4 cases. So the first one, where are you? The first one is kind of our case. So when I select this texture, the interface actually shows me what references this texture. So you can see that it says that the static fields of a class named bundle loader, which references a static list with an underlying array of textures where our texture is, and this is where the reference is. And it even says a static fields, a global variables, anything that reference will not be unloaded. So this thing shows you where the static reference comes from, and it's super useful. Like another issue is, like well, not issue, but case. This one is when you have like a local variable. So local variable, not local variable, but like a private field or something. So here's I load this bundle, and I instantiate texture from it. And I actually saving it into this variable. And you can see how it looks in memory profiler. So I select here. And it says that I have scripts mono behavior, and this is the name of my game object, scripts, which is, I should probably have called it something else. So it tells me that the scripts references this texture, and the texture like basically is held here because of the scripts. And other things like this and like this, they are not referenced by anything, and they will be removed when you call unload unused assets. So yeah, this tool is really cool. You can get more useful information. It probably deserves its own talk, but unfortunately, we don't have time right now. And the very next thing what I want to show you is frame debugger. which for some reason many people don't know it exists. So this is how it works. Go to Window, Frame Debugger, and this is like the interface. So if we run the game, what's going on? Yeah, the game. So I press my easy mode, and I play. I'm playing. So first of all, I hit pause, and here in Frame Debugger, I press Enable, and it shows me all the draw calls, everything Unity does under the hood to render your scene. So we can see here the what? Sorry, I connected to the player. You can do this, but not to be confused, I close it. So as you probably saw, I could connect Frame Debugger to the player itself, not profile it editor. It is also a really cool feature because you can connect your iPhone or like Android and see what's going on there. And basically here, we can go draw call by draw call, get some information about it. But the most important is that we can actually see what every draw call does. So you can see I go draw call, draw call. Every draw call is drawing one guy. And this is already suspicious because we know that Unity should batch these things. So something is probably wrong. And since 5.6, Unity can tell you what is wrong, which makes everything much easier. So if I select this draw call, for example, and I look here, Unity tells you that why this draw call can be batched with the previous one, and says object has different materials. OK, why is that? So I know where these bots are created. It's our famous bot spawner class. And actually, when we create a bot, we do the following. So we instantiate bot's material. And this is why every bot has its own material. This is wrong. Let's comment this. Let's run this again. Not this Unity. OK, we have a few guys. Enable. Wow, we have much less draw calls right now. This is really good. Like we saved a lot of GPU power with just one simple mistake, just commenting a line of code. But we can do better. So let's look at what's going on. I shouldn't do this. OK, so this one draws the background. This one draws some of the guys. And I go next. This one draws columns. The ground, our player. The canvas is drawing here for some reason. Can go and this one draws this little hat. So, and another canvas. You can see that canvas is drawn with like two draw calls. One is background. One is the actual text. And something else. I don't know what this is. The first thing we should notice is precisely this thing. So you can see that if I go here and there, nothing changed on the screen. So this is drawing something which doesn't change the screen. What's that? Draw mesh splash. What? And Unity actually shows you what this draws. So you can see that it draws the splash, the one with the dodge. And the thing is that this splash is fully transparent. So the animator sets transparency to 0. And I actually forgot about it. And this is the mistake I see a lot. The guys coming from Flash do it really a lot. It's super frequent. Like you rendered something and made it fully transparent with a tween or something, but forgot to remove it. And this actually is rendering every frame. It's your Jesus. Fill rate, yeah, fill rate. I remember worse. It fills your, it eats your fill rate and it generally reduces your performance. So you probably need to do something with it. But another thing which is really worrying is why all these things do not batch. Because these guys are pretty simple. Like the ground, the columns, they're all sprites. But they're not batched. OK, let's see how this sprites actually implemented. So if you go to sprites here, you can see that I got some bird enemy, coin, which I don't use, like grass column hat. So I can check the first one. And you can see that it has packing tag game. OK. The next one, packing tag game, packing tag game. Oh, nothing. OK. This should be an easy fix. They're just not set up to be packaged in like one atlas. So game. OK. Apply. OK. Let's start again. I'm playing. Go to pause, enable. OK, wow. Now we see that all these things except the background are packaged in one atlas. This is really cool. We got from like bazillion draw calls to a few. But we still have something wrong, because you can see that there's a dynamic batch which draws everything pretty much. There's canvas for some reason, and there's our hat, this one. So the hat is being drawn separately, but we don't know why. So, and surprisingly, Unity doesn't tell us why. OK. But I think I know why. So to figure this out, since it uses the same material, the Sprite material, it probably uses different atlas for some reason. So I go to Sprite Packer. And I see that we have 3 atlases for our game packing tag. The one contains just the hat. Another one contains just the background. And another one contains pretty much everything else. This is weird, because I would expect this hat to be in the second atlas. OK, let's look what's going on here. Probably something is going on in import settings. OK, so we can see like these guys have pretty much the same import settings. Something changed. Oh, the hat has generate MIP maps. So Unity tries to group your sprites into like, different atlases depending on what import settings you have. For example, it put one other background into the separate atlas because it's not transparent, and all other guys are transparent. So I probably don't need MIP map here, or why? So just apply. And let's see what's going on with our atlases. Sprite Packer, back. Oh, you can see now we have only 2 atlases. This is an improvement. And the hat is right here. So right now we probably would get more, less draw calls. Let's see. OK, let's pause. Enable. We have this. But essentially, we don't. So you can see that we have a canvas. And the hat is rendering after the canvas. This is kind of weird. Let's check out the hat properties. So if we go to, what is this? Bird prefab. And in bird, we have hat. We can see that we have this order in layer set to 13. But if we go to the canvas, where the canvas was, here, we can see that order in layer is set to 10. And if we go to like, birds, the main one, sorting layer is order in layer set to 10. So basically what's happening, Unity is forced to render like the sprites first. After that, it's forced to render canvas. And after that, it renders head. So probably, I don't know who did this, probably me. But let's change this to 10 and see what's going on. Okay, we see the heads, we press pause, go to frame debugger, enable this, and now everything is drawn together, which is super cool. And you can see that we actually came from a lot of draw calls. Unity told us why we had so many draw calls, and just with like, simple, I wouldn't even call this fixes, but I forgot to put packing tag. Okay. We can go from like a lot of draw calls to like 4 or 5 draw calls. So this is frame debugger. Another really useful thing is physics debugger. Unfortunately, physics uses 3D. I mean, unfortunately for my game, because it's like 2D only. So to demo physics debugger, I built this small demo scene using this really cool free assets from Asset Store. And basically how it works, you go to Window, Physics Debugger, you have this window, and when you go to 3D mode, go closer, hide static colliders, press play, physics. So we can see when the physics window is active, we can see what objects are not sleeping. So basically all these pumpkin objects, they have scripts on them which just jitter them a bit. So they never sleep. And you can see that the objects which touch the pumpkins, they are also jittered, but there's like a very small amount, and we cannot see this. But you can see that they never sleep too. So these ones, you can see that some of them drop and they just stop, like this one slept. You see this one, but these ones never sleep. So if you're developing a 3D game, it might be useful for you because sometimes you can have like desyncs between what physics thinks the scene is and what rendering thinks the scene is. So you could have like a object rendered here, but actually physics would think that it's here, and like you can figure out why your objects never sleep and why your scene is running kind of slow. So these are not all the issues with this game, but unfortunately we don't have much time. I showed you how to use the profiler, showed you something about memory profiler and our hidden memory profiler. I showed you that you can use frame debugger and just figure out really quickly what to do if you have a lot of draw calls. And basically, next. So and here's like a small list of third-party tools. So if you are developing for iOS, you are super lucky because you have instruments. If you're developing for Android, with 5.6, we have really great integration with Mali graphics debugger. And I know that guys from ARM are somewhere here, so they probably have a stand at the round building. And you can go and ask how this thing works. And it really works really great. Also, if you're like a PS4 guys, Razer is super good. Well, I wish we had this everywhere, but unfortunately we don't. So the most important thing about this talk is these 3 questions. So first, do you know these tools? So I really hope you do now. Do you use them? So if you don't, please start. And the most important is, does your team use the tools? Because if you know how to do something, how to use these tools, how to use their instruments, you have some knowledge, you really must share this with your team. So this is basically it. If you have like any questions, you can email me. Or otherwise, I'm going to be somewhere around. I think we have like a meeting spot for speakers. So I'm here to answer, all your questions. Thanks.